Hello guys, and welcome to our new session of physics. Today, inshallah, we are going to study the motion and the concepts of motion. First of all, I need you guys to scan the QR code and watch the video, then return back to me. What is the difference between distance and displacement, guys? Distance is the movement of an object through any path from the initial position to the final position, while the displacement is the movement of the same object from the starting point to the ending point in a straight line. So, the only difference between distance and displacement is the straight line, is the direction. If we have an object that exists at point 1, and this object needs to move and reach position 2. If this object moved in different paths, that's mean, and by the end reached the final position, that's mean it moved in distance. While if this object moved from the initial position to the final position in a straight line directly, that means it moved in displacement. So the difference between distance and displacement is only the direction. Distance, guys, never be in a straight line. It's a scalar quantity. It has only magnitude, as we said before. The scalar quantity defined by magnitude only, defined by the value, the number only. It has no direction, as it is scalar physical quantity, and defined as is the total length of the path moved or traveled by an object. It has a measuring unit of kilometer or meter. And if you'd like to convert between kilometer and meter, you have to move in kilometer. You need to convert from kilometer to meter, which is mean kilometer to meter. You will multiply by 1000. If you would like to convert from meter to kilometer, you will divide by 1000. Displacement. Displacement is the straight line distance between an object starting point and ending point. As we said before, displacement is a vector quantity, so it has magnitude and direction, and the measuring unit same like distance. It has kilometer or meter depending on the length of the distance itself. So guys, we can conclude that the only difference between distance and displacement is the direction. If we added direction to the distance, that means the result is displacement. As we can see, guys, in this figure, if this child decided to move from 3A to 3C in a straight line, so the path moved will be a displacement. It has a length of 5 meters. Decided to take the path which passed by the home, it will be a distance and it will take 7 meters instead of 5 meters. So moving to a new term, guys, which is speed and velocity. What is the difference between speed and velocity? Let's say that speed depends on distance, while velocity depends on displacement. So, as the speed depends on distance, so the speed is a scalar physical quantity, like distance exactly. While as velocity depends on displacement, so the velocity is vector physical quantity, exactly like displacement. So the difference between them is only the direction. Speed is a rate at which an object covers distance over time. It has a measuring unit of kilometer per hour or meter per second. It's a scalar physical quantity. It only has magnitude, has no direction. The speed calculated by dividing the total distance traveled by the total time taken to move this distance. While velocity, we said that velocity depends on displacement. Well done. So Velocity is the rate at which an object changes its position over time in a specific direction. It's a vector quantity. It has both magnitude and direction. It has a measuring unit of meter per second or kilometer per hour. Okay, guys. Let's solve this problem. The first problem, a car travels 300 kilometers in 5 hours. What is the average velocity? We said that the velocity, we have a given. These givens are asking about velocity, so displacement. The displacement is equal to 300 kilometers, while the time is 5 hours. So the rule which we'll use to solve this problem is velocity is equal to displacement over time. So the result will be 300 divided by 5 to produce 60 kilometers per hour. Moving to the next problem. Try to solve it by yourself, guys. Find the time required to move a distance of 50 meters, while the speed is 3 meters per second. So the distance is 50 meters. Speed is 3 meters per second. And the required part is, well done, time. So by using the magical triangle, which exists in front of you, if I need the time, so I'm going to hide the time, so the time is equal to distance over speed. So the time is d over v, so 50 over 3 will be 18 point something. And the measuring unit is meter per second. Meter per second. What are the types of speed and velocity? Speed and velocity have the same types, guys. Only the difference between them is the direction. So if I said constant speed, the same definition to define constant velocity. We will use the same definition. If I said changing speed, is the same definition will be used to define velocity. Only change the word of distance into displacement. So if I said that the constant speed is the moving equal distance by equal intervals of time, I define the constant speed. But if I removed the word of distance and replaced it by displacement, so the constant velocity is the moving equal displacement by equal intervals of time. By the same way, changing speed. What is the meaning of changing? In this case, you don't cover equal distance by equal intervals of time. You cover different distance and different intervals of time. So, how to define changing or variable speed? It's the moving of equal distance by unequal intervals of time, or we have another definition, which is moving unequal distance by equal intervals of time. Make one of them constant and change the other variable to be sure that you have a changing and different values of speed. Average speed is found when you move by changing speed. So you are unable to decide what is the speed which you moved through during your journey. So I will say that I started my motion from my house to the school. I started the motion. I said it's a trip from 6 a.m. and reaches the school at 6:30. And the distance between my home and the school is 20 kilometers. So by dividing 20 kilometers over the total time, which is half an hour, so 20 over half will be 40, which is mean I was moving by a speed, average speed, which equal 40 kilometers per hour. 40 kilometers per hour is not a constant speed, but it's an average speed. The value of the speed may be higher than 40 sometimes and lower than 40 other times. But by the end, the average is only 40 kilometers per hour. What is the meaning of instantaneous speed? Instantaneous speed is the speed which you measure and notice at a specific time. At a certain time, what is the speed now? What is your speed now? So you will tell me it's 50 kilometers per hour. You measure the speed using a tool like the speedometer to know what is the speed now at this instant time. So instant speed or instantaneous speed or instantaneous velocity is the speed at instant of time. As we said before, is there a difference between velocity and speed? Yes. The only difference between them is the direction. The only difference between them is speed depends on distance, while velocity depends on displacement. How to convert, guys, between kilometer per hour and meter per second? We said before, converting between kilometer to meter is by time multiplying by 1000 and converting from meter to kilometer by divide by 1000. But here it's a different unit, guys. It's not kilometer and meter. In this unit, you convert between two units. In this conversion, you do a conversion between two units. One of them is kilometer, and the other one is hour. So, converting kilometer to meter, that means you're going to multiply by 1000. While converting from hour to second, which is mean you will divide by 3600. By the end, to convert from kilometer per hour to meter per second, you will divide by 3.6. So the conversion between kilometer per hour to meter per second is by dividing 3.6. And from meter per second to kilometer per hour, multiplying by 3.6. Let's solve the first question, guys. What is the main difference between distance and displacement? Well done. It has, displacement has direction, distance doesn't. What is their displacement if a person walks 10 meters east and 10 meters west? We said that the displacement is the difference between initial position and final position in a straight line. So this person moved 10 meters east, 10 meters east to reach, well done, the final position. Then he returned back again, he returned back again to the previous position. So now, his starting point and ending point is the same. So the difference between starting point and ending point is 0. So, make it a rule, guys. If the starting point is the same ending point, the displacement equals 0. While distance is the total path moved. So in this problem, if you calculating the distance, it will be 20. Here, distance is equal to 20 meter, while displacement is 0. While displacement is 0. So as we said, displacement is 0. If the boy moved from point A to point C, find the distance and displacement. From point A to point C, distance, it will be this path, which is 3 and 5. So it will be 8. So the distance will be 8. So it's one of these answers. It will be one of these answers. And by the way, the displacement never equal to distance unless the object moving in a straight line. So this answer is not correct. So the answer is C. Without calculating displacement. You don't need to calculate displacement. If the boy moved from point A to point D, find the distance and displacement. Let's say that this boy moved from point A to point D in a distance. So the distance is the total path moved. So 3 plus 5 plus 3, because this side is equal to this side, it will be 11. While the displacement is the shortest line joining. Which formula is used to calculate average velocity? We said before, average velocity is total distance moved by total time taken to move this distance. So the total displacement divided by total time, and be sure that he is asking about velocity, not speed. If he asked about speed, so the answer will be A, the distance divided by total time. Total distance divided by total time. While if he asked about velocity, so the answer will be total displacement divided by total time. Which of the following is true for an object moving with constant velocity? The speed is increasing over time. This object covers equal distance in equal intervals of time. The object velocity is changing. The direction of the object is changing. So the answer will be the object covers equal distance in equal intervals of time. Distance time graph, guys. What is the distance time graph? What is a graph first? Graph is the relation between two variables. One of them on x and the other one on y. If you said that one of them is dependent and the other one is independent. The dependent one is y, while the independent one is x. So y depends on x in this change. During the graph, we have something called slope. The slope is the line which represents the changing of y according to x. We have different shapes of this slope, of this line. It may come from the origin or maybe parallel to xy, or maybe has a positive slope or negative slope. Describing the relation between distance and time. So, if the slope is a straight line which is parallel to x-axis, that's mean the distance doesn't change. So the velocity, which represents distance over time, will be 0. As the change in distance doesn't make sense. There is no change in distance. And if the slope is positive straight line. Positive straight line coming from the origin point. And the graph between distance and time. So this graph will represent constant velocity. As there is a regular change of the ratio between distance and time. The ratio itself is constant, and the regular change make a constant ratio. So the ratio represents the speed or velocity. So it's constant. While this graph represents a variable velocity, as it's a curved slope. So the curved slope represents variable or changing velocity. This one is variable. If the slope has a negative sign, so seems to be like that. And this graph between distance and time. So this graph represents negative displacement. What is the meaning of negative displacement, guys? Negative displacement, that means the object is returning back to the original point, is the starting point. To be even by constant velocity or changing velocity. But anyhow, by the end, the object is returning back to the starting point. Acceleration, guys. What is the meaning of acceleration? Just scan the QR code and watch the video, answer the question, and be ready for the explanation. Acceleration, it is the change in velocity. The question is saying that if an object moves with a constant speed, in a circular motion, does it accelerate? Guys? Let's return back to the definition. We said before, velocity is the speed plus direction. So, any change in the speed with keeping the direction is the same, that means you change the velocity. While any change in direction while keeping the speed is the same, that means you change it in the part of velocity so that you make a change in velocity. If you change in the object speed and direction, for sure you did a change in velocity. We can define acceleration as change in velocity. Acceleration is the change in velocity. While velocity, as we said, has two terms. One of them is speed and the other one is direction. So, any change in the object speed without changing the direction is a change in velocity, which is acceleration. Any change in opposite direction without changing in the speed, so it's the change in velocity, which is an acceleration. Any change in the object speed and direction is a change in velocity, which is acceleration. So we can define acceleration as the following. acceleration is the change in object speed or velocity or both of them, which includes the change in velocity. So the acceleration is the change in velocity by time. The object can accelerate by changing its speed, direction, or both of them. Types of acceleration, guys. We have two types of acceleration. One of them is called positive acceleration, and the other one is called negative acceleration, which is called deceleration. Positive acceleration, the object is speeding up, and its initial velocity less than the final velocity. While negative acceleration, the object is slowing down, and its initial velocity greater than final velocity. The measuring unit of acceleration, guys, is meter per second square or kilometer per hour square. How did we find this unit, guys? We said acceleration is the change in velocity over time. So the velocity is measured by meter per second or kilometer per hour, and time is measured by second. So the final unit will be meter per second squared. Meter per second squared. Mathematical equation of acceleration. We said, guys, acceleration is the change in velocity by time. So A is equal to the change in velocity by time. So A is equal. Change in velocity means that V final, the final velocity, minus V initial over time. Any change in occurs in our life occurs by time. So, as we said before, A is equal to the change in velocity by time, which is V final minus V initial over time. V final is the final velocity, V initial is the initial velocity, and T is the time. The graph which represents acceleration, guys. This graph is between two physical terms. One of them is velocity and the other one is time. As we said, acceleration is the change in velocity over time. The first part of the graph represents positive acceleration, as this part has a positive slope, which is mean V final is greater than V initial. While the second part represents acceleration of zero, as there is no change in velocity by time. The velocity here is 8 meter per second. Here also is 8 meter per second. So there is no change in velocity. While the last part of the slope represent a negative acceleration, as the speed decreases from 8 to 0. So V initial in this part is greater than V final. So if we subtract it, V final minus V initial, the answer will be negative. The answer will be negative value. A car accelerates from 15 meters per second to 35 meters per second in 4 seconds. What is the acceleration of the car? So by applying the rule, A is equal to Vf minus Vi over time. So the rule will be 35 minus 15, as 15 is V initial, while 35 is V final. And the time is 4 seconds. Here is the time, over time. So 20 over 4 will be 5 meter per second square. So the answer will be 5 meter per second square. A bike initially was moving at 10 meter per second, slows down to complete stop in 5 seconds. The initial velocity is 10, while the final velocity is the complete stop, which is 0. So the final velocity is equal to, well done, 0. And stop during 5 seconds. the time. As we said before, A is equal to V final minus V initial over time. Be careful, guys. Don't say that. I'm going to subtract 10 minus 0. It's wrong. This type of acceleration is descending acceleration. So it must have a negative sign. Must have a negative sign. So 0 minus V final minus V initial, which is 10, divided by the time, which is 5. So the answer will be negative 2 meters per second square. An object starts at rest and reaches a speed of 30 meters per second in 10 seconds. What is the acceleration? So easy, guys. Starts at rest, which is mean V initial is 0. And reaches speed of 30 meters per second, so this one is V final through 10 seconds. Here is the time, A equal V final minus V initial over time. So it will be 30 minus 0 over 10. The answer will be 3 meters per second squared. I need you guys to know, are we able to use this relation to find the distance, the value of the distance through an accelerated motion? The relation says that V is equal distance over time, which is mean D is constant and time is constant, so V is constant. Or even to be an average, so I have a total distance over total time. But while moving through acceleration, the ratio of D over time change as the velocity change. So to find the displacement or distance using this rule, which value of the D you will get? Which value of the displacement you will get? The one which covered by a lower speed or the one which covered by a high speed. So you are unable to find the displacement or distance through accelerated motion using this rule. For that, we have different motion equations. We have 4 motion equations, guys. The first one, D equal V final plus V initial over 2 multiplied by time. Here the acceleration is absent. The second one is D equal VIT plus half AT squared. Here final velocity is absent. The third one, V final squared equal to VI squared plus 2D. Here's the time is absent. While VF equal VI plus AT, here the displacement is absent. During the using of motion equation, guys, we have 5 different variables, which are V initial, V final, acceleration, distance, and time. Through any problem, he will provide 3. Ask about 1 and hide 1. So he will provide 3 of them. Ask about 1, hide 1. And my key of calculation is the one which is hidden. There is a song for Angham saying that ما جابش سيرتي ما سألش عني. ما جابش سيرتي ما سألش عني. So the one which is hidden is the key of solving. During the presentation, if the A is absent, if the acceleration is absent, ما جابش سيرتي ما سألش عني, I'm going to use simply this rule. If the velocity, final velocity is absent, I'm going to use this one. If the time is absent, I will use this one, and so on by the last one for the last equation. If the displacement is absent, I'm going to use this equation. Let's solve this one, guys. Choose the correct answer. An object travels at a constant velocity, 10 meters per second for 5 seconds. How far does it? So That's mean I'm going to use the normal rule of velocity v equal distance over time. How far? He is asking about distance. To be sure, all of the unit of distance. I need d, so d will be v times t. So it will be 10 multiplied by 5. So the answer will be 50. The answer will be 50 meters. A car accelerates from rest with an acceleration of 3. Acceleration is 3 meters per second square, and started from rest. That means v initial is equal to 0. And the time is 4 seconds. What is the final velocity? ما جابش سيرتي، ما سألش عني. Which term? Well done. He didn't mention displacement by any way to be a given or required part. So, returning back to the equations, when the equation which is displacement is absent, is v final equal v initial plus et. So, I will write the equation. V final is equal to v initial plus at. V final is the required part, equal v initial, which is 0. A is 3, multiplied by t, which is 4. So the answer will be 12. 12, I'm asking for v final, meter per second. 12 meter per second. In a velocity time graph, if the slope of the line is 0, if the slope of line is 0, slope of line is 0, that means the line is a straight line which is parallel to x direction, and the graph between velocity and time. This graph represents a constant velocity. And as the velocity is constant, that means the acceleration is equal to, well done guys, 0. Moving to a new term, which is free fall and vertical projectile. I need you guys to scan the QR code and watch the video. Then, let me ask you a question. If we dropped a stone and a feather from the same height in the presence of air, which one going to reach the ground faster? Of course, the rock. And in the case of absence of air resistance, there is no air. They are going to reach the ground at the same time, as the force which controlling the process of falling is only the gravitational force, and the acceleration of gravity is constant for all falling objects. So it will change its velocity at the same ratio. And no one of the equation of motion which we studied contain or includes a mass as a variable. So V initial and V final, in the case of absence of air, they don't depend on the mass. So, well done, the acceleration is constant. Let's try, guys, this simulation. Is there a difference between projecting different objects and letting it fall down in the absence of air resistance or not? So I'm going to use, at the beginning, a cannonball. And I'm going to project it from 0 position. The height is 0. And I will project it. It will reach a certain height. By measuring this height, I will find it 11.47. By changing the object itself and use another object, like a car, and also in the absence of air, and I'm going to project it vertically, like this, and measure the height, it will be the same. 11.47. Let's do the same action with the same object, which is the car, but at the existence of a resistance. The first time was 11.47. Now, the car reached only 11.4. The difference, 7 centimeters. While if we projected another object which should reach 11.47 at there's no resistance, because I'm pumping them with the same force. If I let the air resistance, the process including the air resistance, so this ball will reach 11.24. So that's mean, guys, it differs according to the existence of air lock. When I'm talking about free fall and vertical projectile, that means there is no air resistance. So the object will accelerate by the same ratio. And this acceleration is equal to the acceleration of gravity. The acceleration of gravity has a certain value, which is G equal 9.81 meter per second squared. Okay, guys, which rules we are going to use during the calculation of V initial and V final for vertical and free fall, vertical projectile and free fall? We are going to use the same motion equations. Motion equations are applied for vertical and free fall, vertical projectile and free fall, with it changing some terms. But during the solving of problem itself, don't change these terms. Just know that the distance is the height and the acceleration is gravity. But there are some concepts. You have to know before solving any free fall and vertical projectile problem. You have to know that, guys, he will not give you some terms during the problem, during asking you about a physical term or giving you a problem. Some terms will be hidden, not unknown, not neglected, but he depends on that you know the concept and how to solve these problems. Let's say that for free fall, when the object falls freely downward, it has V initial of 0. As I drop the object, so it started its motion from 0. And by reaching the ground level, V initial is maximum. And of course, A, which is G, is 9.81 meter per second square. When the object is, this one represents free fall. But when we talk about the vertical projectile, V initial will be maximum. And the one which will equal to 0 is V final. And the acceleration of gravity will be negative 9.81 meter per second squared. So guys, you have to know that he mentioned that the object is freely fall, V initial will be 0. Even though if he didn't mention that, don't consider it as ما جابش سيرتي ما سألش عني. And also, as the object is projected vertically, the V final will equal to 0. Will equal to 0. Is it clear, guys? But if the object projected, guys, but instead of moving vertically, it moved between two axes, X and Y. It moved, making a curve. This curve is called parabola. This motion is called a projectile motion. In this case, we are unable to use the rules of horizontal motion or vertical motion because we have a new dimension which is between X and Y. So now we are dealing with the motion in two dimensions. These dimensions in X and Y. The motion in two dimensions, the motion of the object in two dimensions must be analyzed into two components. One of them X and the other one is Y. One of them is X and the other one is Y. Let's see that, guys. Here is an object which is moving between X and Y. Here is X and here is Y. This object moves in two dimensions. Physics and math can't understand the motion in two dimensions. So we have to analyze this motion into two components. One of them in the X direction and the other one in Y dimension. Analyzing them depends on the angle between the component and X direction. The rules are, if we need, let's say that the name of the main vector is R. The main physical term is R. So if we need the components, we need R in X direction and R in Y direction. Rx, which is the component of R in X direction, will be R cosine theta, while Ry will be R sine theta. So guys, Rx is R cosine theta and Ry is R sine theta. And if we have Rx and Ry and need to find R itself, so R will be following Pythagoras rule, Rx squared plus Ry squared. And by the end, if we need theta will be tan minus 1 y over x. Here are the rules to make analysis and to separate R into Rx and Ry. Rx and Ry. So, if the object is projected by an angle to the horizontal x, the initial velocity has two components. One of them in X direction and the other one in Y direction. Moving with these components in each part of the motion. For the X component of V, let's say Vx. Vx has a constant value and never change because this component is horizontal, which means the gravitational force doesn't affect it. So Vx is always equal to Vix, which is Vi cosine theta. while the one which changes during the motion is Vy. It starts the motion with Viy, and this value decreases as we're going up. At the maximum position, there is no Vi. Vi is equal to 0, as the object going to move horizontal only. After that, the object will fall down. By falling down, the velocity, the vertical velocity, will increase again by negative value, as the object now is moving in opposite direction of the projection motion. To reach the ground again, and by reaching the ground, that means you reach the initial velocity by negative value. During this term, or during this problem, we can find different values. R is the range, which is the horizontal cover distance from the starting point, the projection point, to reaching the ground again. H is the maximum height reached by the object. T small is the time of the maximum height, while T capital is the total time of motion. How to find this rule, guys? First step, in the projectile motion, you have to find the component of V initials. All of the rules to find R, H, T small, or T capital depend on V initial in Y direction and V initial in X direction, the components of initial velocity. If we need to find the time of reaching maximum height, so it will be negative Viy over G. In all of this equation, guys, we will substitute G equal to negative 9.81 meter per second square as the projectile motion moving upward. So the object moves against the gravity, so its speed decreases and it has a negative acceleration motion. T equal negative Viy over G. T capital, which is the time of projection, is equal to negative Viy over G. Negative 2 Viy over G, which is mean the time, or the total time, is double the time of reaching maximum height. Reaching the maximum height, negative Viy square over 2G, and the range is Vix over T, as the range depends on the horizontal velocity. When a projectile is launched at an angle theta to the horizontal, which of the following is true about horizontal velocity? It remains constant through the flight. What is the shape of the path followed by projectile launched at an angle? It's a parabola. Which angle of a launch will give a projectile the maximum range? The maximum range depends on 45. 45 is the angle which gives the projectile the maximum range, horizontal distance. An object is projected with an angle velocity, with initial velocity 30 meters per second, with angle 45. What is the maximum height reached? So here is the Vi, and here is theta. The first step to find Viy. Viy is equal to Vi sine theta, Vi sine theta. So it will be Vi, it will be 30 multiplying by sine 45. So VIY will equal to 21.21 meter per second. Substituting in the rule of maximum height, H is equal to negative VIY squared over 2G. So 21.21 squared over 2G, 2 times 9.81. The answer will be 23 meters. The answer will be 23 meters.